Sure.
Let me do this. Hello, everybody. Welcome. This is the Enterprise AI virtual user group. We have been away for a few months and we're coming back. Now that virtually all the user groups are virtual, it was natural for us to come back and come back with a vengeance. So we have a great presentation today. Hopefully it will give us some retreat from the situation, and we can learn a bunch of interesting things from Jerry Carroll. He is the speaker for today. And also I wanted to introduce you to Vivian. Vivian is with me organizing the group. So
hi everyone.
And here's Jerry. So Vivian and I will leave the stage to Jerry. You can write comments. We can see your comments as they come, and we let Jerry know, because he cannot necessarily see them while he's presenting. We will just ask him and the questions, and he will do his best to answer. So here's Jerry. Maybe you can start by talking about yourself a little bit and continue as you would normally do. Thank you, Jerry.
Sure.
We'll take ourselves out of the picture.
Okay. So hello, everyone. I'm happy to be here. I have to admit, this is the first time I've used or even heard of StreamYard as a way to stream directly to YouTube. So here at IBM, we use Cisco WebEx, but we tested this out Wednesday. Should go smoothly. I've been with IBM a long time, I have to say, and for the last 3 or 4 years, I've been working on AI. And so hopefully you're going to get a lot out of this session. We did it live in Jacksonville, at the end of February. And I do have a few slides to talk about H2O, the company, the partnership with IBM. But let's face it, everyone loves a demo rather than a bunch of slides. So the bulk or majority of the time will be spent with doing the demo. And as Eyal said, I can't see the comments that are coming in, so they're going to be monitoring the comments. And Eyal and Vivian, will feel free to interject, ask your questions to me, so we can keep this interactive. So I am an AI system architect, and like I said, we're going to start with a few slides. Are we good then, Eyal?
Yes,
the slides up.
We're good. I'll put the slides up. 1 second. I'll remove myself again. You're on. You can get started, Jerry. Your slides are up on the screen. Oh, but your picture froze. Okay, guys, looks like we lost Jerry. Hopefully it's temporary. But I guess I should do the presentation instead. No, I'm not going to do it. Let's wait for him to rejoin us. Okay. This is something we could expect in a streaming presentation. I hope anybody can still see me. I'm going to ask it with if you guys can still see me and hear me, please write a comment. Otherwise, I will know that it's me that is disconnected from the world. Okay, it looks like it's not me. It looks like I'm still online, but nobody else is. Okay, so I feel very awkward. I lost everybody. Oh, here, maybe Jerry is back. Jerry, you back?
Yeah, I am back.
Okay, great.
I'm not sure what happened. Wi-Fi connection situation. I'm not sure. Do we have everyone on YouTube? Should I get started? Uh-oh.
I'm sorry. When I remove myself, you can't hear me. I think you're good. Share your screen and we'll get started again.
Okay,
Also,
that's true.
people who are a little bit late, they will not miss anything. They will start from the beginning now.
Okay. All right. I'm sharing the screen again, and we're going to PowerPoint. Hopefully you see PowerPoint.
I do not see your screen yet. And I think we lost you again. Oh, or maybe that is the screen. Okay, we can see the screen.
You can see the PowerPoint?
Yes.
Okay. All right. Hopefully this goes smoothly. So what I'll be talking about for the next 15 or 20 minutes before we jump into the demo itself is the wonders of H2O Driverless AI in conjunction with IBM's GPU-enabled power systems. So let's start with a little demystification of AI, and depending on your role, if you're a data scientist, this is no new news. But if you're not, if you're a line of business person or an infrastructure person, then this sometimes is a good, little refresher, right? So artificial intelligence has been all the rage for the last 4 or 5 years, and how it's being delivered is mainly through machine learning and deep learning algorithms and models. Okay, and so machine learning. That is the focus of what H2O Driveless AI is really good at. Machine learning typically uses structured tabular data. Deep learning, yes.
Excuse me for interrupting. Your voice is a little choppy. Perhaps try to disable your camera to basically stop the camera so we just hear your voice, and because I'm not showing your face anyways.
Okay. Okay. I wonder if we should try. Let's see here. The voice is choppy.
Well, right now the voice is better. I'm not sure if you change anything, but I can hear you better at the moment.
Okay. All right. So this is a little tricky. All right, let me. So how about now?
Since your voice is okay now, we can just try again and see if that works.
Okay. I mean, I just got closer to my computer. Okay, so machine learning, deep learning, this is the way artificial intelligence is being delivered and executed in the marketplace now. Machine learning is more about using structured tabular data. Deep learning is more about computer vision, robotics, natural language processing. You're using oftentimes, videos and images, and quite frankly, deep learning and computer vision applications is really where some of the most exciting and new use cases are being developed, and IBM has some products in that marketplace. But machine learning is really the bread and butter of what enterprises use still to do what they have to do, right? I almost think of it as analytics 2.0 or analytics 3.0. And if you're not familiar with machine learning, right, and a lot of data, artificial intelligence and data science is terminology. So we're going to talk about algorithms and models, right? And so those that aren't familiar with that, I like to make an example of something that everyone can relate to. If you went through algebra in junior high or high school, the simplest of all models is linear regression. And if you think back or visualize what that used to be, right? You had an XY axis, and on the XY axis, you had maybe a series of 10 dots, right? And each of those 10 dots on the XY axis had an X coordinate and a Y coordinate. And your teacher said, well, I want you to find the best fit line to those 10 dots on the graph. And the model that you would use would be y equals mx plus b. And the technique you would use to figure out what m, the slope of the line is, and b, the y-intercept is, as I recall, was least squares, right? You had to do some least squares, a little trial and error. But at the end of the day, you had a model that said something, for example, like y equals 2x plus 5, right? Y equals, and the slope m was 2, and the y-intercept was 5, and you based it on those 10 dots. Each had an xy coordinate. You can think of those 10 xy coordinates as your training data. And so now you have trained your model, y equals 2x plus 5, so that the next time you get a new value of x, you can put it in your model and predict what the value of y is. And that's basically what models and algorithms in machine learning do. Now, while linear regression is still used, the models and algorithms that are used are significantly more sophisticated than that, right? We've used logistics regression, we use support vector machines, we use decision trees, we use gradient boosting machines. There's scores and scores of different machine learning models and algorithms, and what H2O does is make this easy. All right, y'all, can you see the next slide? Hopefully that shifted.
I can see it.
Okay, very good. I think we're rolling now here. How does the audio sound? Okay?
Sounds great to me.
Okay. All right, so the only reason I wanted to put this here is to let you know that here at IBM, and I am basically an IBM AI sales engineer, right? So I'm part sales and part technical. And what we're going to focus on, right, today is up in the upper right-hand corner, H2O Driverless AI. It does automated machine learning for basically tabular data. They do have some capability for natural language processing. We'll see that in a bit. But at IBM, we also have another product that used to be called Power AI Vision. It was just recently, like within the last couple of weeks, rebranded to IBM Visual Insights. The reason I mention this is it is targeted at the computer vision type of applications, okay? And it does a similar thing. H2O makes machine learning easy. IBM Visual Insights makes deep learning easy. Both of these products are point and click type of products, right? What I will say is that we also, and I'm sure if you're familiar with IBM, you've heard Watson as one of our offerings, and you're saying, well, what about Watson? And we do have a very strong set of capabilities around the Watson brand, and I show you them there: Watson Studio, Watson Machine Learning, Watson OpenScale, Watson Machine Learning Accelerator, and these are all complementary products. What I will say, while H2O Driverless AI and IBM Visual Insights are point and click type of products, the Watson Studio is more of, you need to know Python or R. It's more of a programmatic environment. It does support a broader variety of applications, AI included. At the bottom, and this is where I come from, I'm from the IBM Systems Group, is we have IBM Power servers. They're GPU accelerated. We've partnered with NVIDIA. And then storage, of course. Lots of storage is typically required to train these models. And so IBM has a strong portfolio of storage to support that. I like this slide just because it shows the totality of IBM's AI offerings. I don't like it because it implies some kind of prerequisite or stack. The way I really would do this if I was in the marketing department is I would have the GPU accelerated servers and storage kind of in the center as your infrastructure, and all of these different complementary AI software products around that, around the basically the hub, the infrastructure. Okay, so the other thing I'd just like to say, I kind of got on this point a little bit earlier, is that while these are the AI domains, and the ones that are addressed by H2O Driverless AI that we'll be demoing are really the ones with the blue arrows, right? Machine learning and natural language. And what this is trying to represent here, the numbers aren't really that important. It's a McKinsey study. It's just the relative size of where the focus is in AI. So like I said earlier, computer vision, where we're using videos and images to generate AI applications, those are, oftentimes completely new use cases. But really, machine learning is where you're doing things that are bread and butter to an organization and an enterprise. And you can see from a relative point of view, the domain addressed by machine learning is the biggest in AI, at least at this point in time. I do point out natural language here because H2O does address that. It does have a, quote, niche capability for natural language processing, and that is deep learning. So they do go off of their core and they use TensorFlow, which is a deep learning, very popular deep learning framework from Google. And that is incorporated as well in their driverless product. And you can see, right, we hear a lot about autonomous vehicles, but in the grand scheme of things, it's relatively small, at least now, compared to machine learning and computer vision. We've got robotics as well, and virtual agents. And virtual agents or chatbots are very important. Watson has a very strong, we have a Watson Assistant product that has a lot of adoption. Actually, with COVID-19, it's one of the three prongs that IBM's bringing to the table to help first responders and people and enterprises. Is we have a chatbot focused on answering COVID-19 questions. So good stuff. So let's talk a little bit about H2O. IBM partnered with them last summer, the summer of 2018. They were founded in 2012, and you can see they've got some serious partners and investors, right? NVIDIA, Wells Fargo, and what they've done here is through their H2O product line, they've really done a great job of addressing the marketplace. And the way they did that is with a very small team. And I don't know if you're familiar with Kaggle or Kaggle, but it's the largest data science AI community out there. And they basically, oftentimes they sponsor competitions, AI and data science competitions. And individuals and companies partake in those competitions. The actual demo that we're going to see today is actually a Walmart hosted competition for demand forecasting. And so what happens is for the very best data scientists that go out and attempt these challenges, is they get ranked depending on how accurate their models are in addressing each of the corporation's challenges. And if you're a very good data scientist, you're a master, and if you're the best of the best, you're called a grandmaster. And so what H2O has done is hired a number of these Kaggle grandmasters and masters. So we've basically got the best of the best. And what they've done with their software is basically codified their brains, right? So all of the techniques, all of the tips, all of the best practices that the individual best data scientists in the world, have developed they've basically codified into their H2O Driverless AI product. So we can take advantage of that. And this is just to show that even though they're a small company, right? You saw on the previous slide, approximately 220 employees, lots of adoption, right, across the Fortune 500 companies. And to the right, you can see specific companies that are using H2O products. But, right, 18,000 companies right now are using H2O. And they do have, as we'll see, I think on the next slide, yes. So what are their offerings? On the right is what we'll basically be demoing in about 10 minutes, which is Driverless AI. On the left is their open source suite of products, right? H2O version 3 is open source. They have another product, which is Spark, and Spark is very good for data processing in conjunction with H2O. They call that sparkling water. And then they have H2O for GPU. So these three products are basically open source products and widely adopted across those 18,000 enterprises across the world. And a subset of those have actually paid money for the driverless AI to the right, right? I think that's all I want to say on that slide. This is a high-level component diagram of what H2O Driverless AI is made up of. You can see at the bottom, right? I guess I'll use you can see, right? We've got GPU-enabled servers. And again, IBM, what we bring to the table is our IBM GPU-enabled power server, the AC922. And to the left, you can see automatic visualization. We're going to see the incredible visualization they provide of the data once it's been cleaned up and curated. And the reason one of the reasons it's so wonderful is because they recruited one of the lead data engineers from Tableau, right? And so Tableau has always been great for their visualization, data visualization, and they've built that into the product here. You can see that the open source components that we just mentioned, like H2O version 3 and H2O for GPU, also make up their driverless AI product. Data table is more about bringing the data in. And as I did say, right, they do support natural language processing applications, and that's why they have TensorFlow, because TensorFlow is really a deep learning framework and not machine learning. And then up here you can see recipes, okay? And they have recipes for time series, and that's one that we'll actually be doing a demonstration of time series, stacking, feature engineering, very important. And you know, I mean, really, what recipes are Python code snippets, right? So the best of the best, right? The H2O data, Kaggle grandmasters and Kaggle masters have developed these recipes, right? Which are Python code snippets to do things and make it easier for us, the non-data scientists, as well as the budding data scientists, to do time series and feature engineering. And then lastly, machine learning interpretability. To be able to interpret your models is also, depending on the industry, important. Now, I work in the retail industry, retail consumer products, travel and transportation. Machine learning interpretability isn't all that important, but just to give you an idea, right? If you were working in the financial services industry and you're in the mortgage part of that industry, right? You can't just tell a customer that they didn't get the mortgage, they didn't qualify for a mortgage, or they did. You know, if you didn't qualify for a mortgage, the customer wants to know why. And so machine learning interpretability facilitates that, right? And then once you've trained your model, all right, through using these technologies within H2O Driverless AI, you have to deploy it to production, right? And that's what we do with the scoring pipeline. We deploy it into production, whether it's into the data center, another GPU-enabled, or on the edge, right? In video cameras or whatnot. So that is a high-level component model of driverless AI. That is well recognized. They've done really well for themselves. Even a small company, 220 employees.
Jerry, your voice is breaking up again. I'm sorry. I'm guessing I'm not the only one who can hear it, but
okay, let me get a little closer then.
It sounds better already.
Okay, let me just remember to stay close. Do you have me on the video or just no?
I can see you, but it's not on the video. So you can turn off your camera. You can stop cam on your controls.
Okay. I mean, it's fine. It's just that I am pretty close to my laptop now. I don't want to, be looming large over here. Anyway, so the basically this shows that both Gartner, Forrester, and another company I'm not as familiar with, may think very highly, right, of H2O and the product suite. Okay, so what are the challenges of adopting AI in the enterprise, right? And, so really it comes down to the 3 T's: talent, time, and trust, right? There's just an absolute dearth of data science talent right now, right? There's only so many grandmasters and so many masters as scored by Kaggle. So if we can codify their brains within H2O Driverless AI, that's a good thing. Also, building these models, right, and deploying them, we can't take months, right? Things move too quickly to take months and months to build these models because oftentimes by the time they're built, they're a little bit obsolete. And then last on the right, there's a lack of trust, right? In the fact that, we have to have explainability or interpretability of the models and what the models are basically forecasting. So how does H2O Driverless AI, and I would also argue and make the case for IBM's AC922 GPU-enabled power server, address these challenges? Well, as we already mentioned, right, they have, while a small company, 220 or so employees, they have the top data scientists in the industry, and right, that we've codified their best practices into this driverless software. Secondly, time to insight, right? There's 2 aspects to this, and you're going to see in the demo how they automate so many of the things that are hard in doing these AI models, right? The feature engineering, the hyperparameter tuning, even selecting what is the right algorithm or model that I should be using, right? Is it XGBoost? Is it logistics regression? It really automates a lot of that, and you're going to see that in the demo. But also on the hardware side, GPUs from NVIDIA, and we've partnered with NVIDIA. Open source software has been around for decades, right? Red Hat is one of the leaders in that. But IBM, what they did 5 or 6 years ago was we opened up our hardware, and we opened up our power hardware, and we have some of our initial partners when we did this, we call it the Open Power Foundation, was Google and NVIDIA, as well as Mellanox. I can't remember the other one. So anyway, the GPU acceleration is key to it, and our partnership with NVIDIA is key. And one of the things that we did that was different than everyone else is we created a high-speed bus. Right now it's in its 2nd generation. It's called NVLink. And this NVLink high-speed bus between our Power 9 CPUs and our Power 9 memory to the NVIDIA GPUs and GPU memory provides huge differentiation for us against Intel-based GPU servers. And actually, we've got some testimonials from H2O itself on that. And then trust, right? You have to be able to explain, why your model made a prediction. So I'm not going to go through this. We're really going to see this in the demo. but this is what driverless AI brings to the table: simple, fast, accurate, interpretable models. And H2O Driverless, they have a lot of
Jerry, you're breaking up again.
for most of the industries, they have pretty good.
Jerry, sorry to interrupt you again. I hope you can hear me, but
Yeah.
I hear you very badly at this point.
Let's see here.
Okay, I hope Jerry is reconnecting. So let's give him a couple of minutes, and hopefully he'll be back with us. I'm going to maybe pick on Vivian. Vivian, would you like to say anything to our listeners? Actually, I might have lost her as well. Okay, I see Vivian saying that there is no sound. Oops. Can anybody hear me at the moment? If you can hear me or see me, please give me some feedback. Okay, so here is Jerry. He's back, I think.
I mean, I'm sitting right next to my router. I moved in case, I mean, I don't know if that was it, but
Okay,
all right, can you?
You sound great right now, so let's just add your screen back, and we can.
All right, let's get the screen back. All right, here we go, folks. All righty. All right.
Yeah.
So is this where I left off, EL?
Yes.
Okay. All right, so this is all about H2O Driverless AI. These are actually from their website, customer references to the success they've had. I am going to, I'm going to go to full screen so you can see it better. I'm going to take a look at PayPal. The reason I like PayPal is for a couple reasons. One, it uses our IBM Power GPU-based servers, right? And I'm IBM, so. And what they found was a 6x speed up when they used our IBM Power GPU-based servers, which is really good. The other thing, and this is really gets to the value of H2O Driverless AI, right? PayPal, you could argue that the #1 use case for PayPal is financial fraud detection, okay? And they have a team of data scientists and data analysts that have been working for 10 years and have continued to improve the accuracy of detecting fraudulent financial transactions. And the best they got to was 89%. When they deployed H2O Driverless AI on IBM Power Systems, they were able to improve the accuracy of fraud detection 6%. Up to 95%. I mean, and that's the kind of stuff that hits both the top and bottom line. So that's amazing. I did include a link, EL, in case you're sharing this out to the community later. There's a YouTube link. It basically has one of the PayPal lead data scientists, and somewhere around between 15 and 20 minutes, they talk about the value of the IBM Power GPU server and the overall solution, and in driving the improvement of 6% accuracy. This is another one. This is actually in my industry. That's why I included it. It's a leading retailer. 290 stores. They bought a couple of our products. They deployed our Power GPU servers with two products. One is our Watson Machine Learning Accelerator. You may recall that from the intro slide that I had in slide 2 or 3. Again, that requires a little bit more of Python coding, and H2O Driveless AI. And these are the use cases here that they're addressing with both Watson Machine Learning Accelerator and H2O Driveless AI. Personalized product recommendations, supply chain optimization, price optimization, next best offer. Okay. And you can see some of that. I provided a link there at H2O of more typical retail use cases. Okay, so this gets a little bit to the value that IBM and particularly NVIDIA GPUs bring to artificial intelligence. This is the use case here is basically U.S. Census data. It's predicting income, okay? And what they did is they did initially on an Intel Xeon CPU only server, right? And for this model, you could see it just got started out. The model's trained and evaluated, the number was 36. When we moved it over to a GPU-enabled, NVIDIA GPU-enabled server, you could see that the models trained and evaluated were 3,670. So in the same amount of time, when we're trying to predict income across the US, the GPU-enabled server would just about completed its analysis and came up with the best model and the most accurate model in predicting income. And the CPU server basically had just started out. So GPUs do make all the difference. This is a combination. If you look down here, I do, again, just like I did earlier, this is this link, this H2O link, is basically a link to H2O site, and it's a testimonial by the CEO of H2O. And it talks about the value of driverless running on IBM GPU-enabled power servers. 30x speed up on machine learning algorithms, training and testing versus CPU-only servers. 2x faster data ingest on the IBM power servers. 50% improvement in feature engineering, the speed up feature engineering. And for time series, of which we're going to demo, they saw a 5x speed up using IBM GPU-enabled servers. So it is a good testimonial to what IBM brings to the table with our IBM GPU-enabled power servers. And right now we have two models. The AC922 has been out for about a year, and we just actually came out with a new model, IC922. It's a little bit more geared toward inference, right? Once your model's trained, you want to deploy it out into potentially in retail, right? I'm retail, out to the stores. So you would put an IC922, a smaller, lower cost server with lower cost NVIDIA GPUs, the T4s out there to do whatever it is you've trained it or want it to do, right? Okay. We do also have, for existing IBM customers that have power systems, we do have a very low cost, I'll say very, it's not a crazy Eddie deal, but pretty close. So what we're trying to depict here in this illustration on the left is an existing power customer. Now, power could be an Power I customer running DB2, or it could be a Power AIX customer running either DB2 or Oracle. And we're assuming that that's what they have installed in place, okay? And what we're offering customers is, and we started offering this second half of last year, and the deal continues, is this: a bundle, a very specific model of either the AC922 or a brand new IC922 in conjunction with the H2O Driverless AI license, as well as some H2O onboarding services. So basically you get three things and it's less than $100,000. Okay. So but the bottom line is in terms of what it does is it takes the data, right, out of your legacy, either Power I or AIX system. We load that training data into our AC922 running H2O Driverless. We do the training, the necessary training, and then when it's met the proper level of accuracy, we deploy it out into production, and that's what step 3 is. And the nice thing about this is we deploy it right to their legacy system. So 1, 2, 3, it's as easy as that. It's less than $100,000 to get started, and it's a great way to leverage your existing IBM Power environment and get into the world of AI at a relatively low cost. All right, so we are going into getting ready for the demo here. So this is, you're going to see different versions of this. It's all the same thing, right? The variations of a theme on the AI pipeline, right? You've got to collect, first of all, once you have to determine your use case, right? And in our use case, it's going to be demand forecast or sale forecasting, right? That's what we're going to be doing. And then what you have to do based upon your use case is determine, what data do I need to feed in to our software in order to develop a model that would accurately predict. And like I say, in our case, it's going to be sales for the future, right? So data integration, data transformation, and I'm going to do one more click, and we're going to see where driverless AI plays. And you can see that where driverless AI sweet spot is pretty much the entire AI pipeline from beginning to end, with the exception of the data engineering part right here. It does a little bit of that, and we'll see that in the demo, but not, it's not its strong spot. Where it does excel is all the other difficult tasks. Boy, and this is a little bit more detailed, and you can see what's interesting about this, a couple different things. This is their version of the pipeline. You can see that the data sources are plentiful, right? From Hadoop, SQL, Snowflake, Amazon, BigQuery. We drive that into driverless AI software, and we create a production-ready deployable model. The nice thing about, the other thing I want to mention here is extensibility, right? They understand that while they have the best data scientists employed at H2O, and they have come up with some fantastic software to make the life of the data scientist much easier, you may have your own expert data scientists with their own capabilities. And what they have a feature called Bring Your Own Recipes, and you can upload your own recipes, and it spans whether you have algorithms or models, right, that you want to upload into the driverless AI platform to augment what H2O brings to the table, data transformations, right, and even scores, right? You're going to see that they provide some scores, but there's additional scores out there that you may want to include. And again, you can see the software is powered by IBM and NVIDIA. We have a strong partnership. All right, we are getting close to the demo. What's very important is to understand the use case. And this is right from CNBC, right? I watched a lot of CNBC, especially lately, as we enter our bear market. So this is, again, for our sales forecast use case. This is a huge opportunity, right? Across all retailers, they're losing close to $2 trillion a year, right? And it's a function of out of stocks, overstocks, and that's what we're going to be focusing on. So the out of stocks and overstocks, right? Out of stocks, they're losing $634 billion a year in lost retail sales. Overstocks, $471 billion in lost revenues, right? And so it's very important to forecast and have the right products in the right stores, and that's what this model is doing. So So what we've done is we've gone out to Kaggle, right? And Walmart has provided some data for 45 stores. Obviously, Walmart has many, many more stores than 45, but they've provided some data sources, and we're going to start with that. And again, what we have to remember is the end result is we want to be able to predict future sales, right? So we can have the right product in the right stores in the right departments at all times, and not have overstocks and not have out of stocks. Tremendous amount of lost revenue there. All right, so I think we're time to do the demo. I am going to flip over to my browser. Is everything okay, Eyal?
Yes, everything looks fine.
Okay. Fine. All right. So we're going. Here's the H2O logon, and what we're doing is we're actually hosting this up in one of IBM's Poughkeepsie client centers. I'm going to log on. I'm not going to save that. And this is H2O Driverless AI. It brings us to the first page it brings us to is the data sets. Okay. If we look up top, this is how you navigate in H2O Driverless AI is projects. And projects are basically a combination of the data sets and experiments that you're doing. So you typically combine and experiments. You could think of experiments as models, right? It's a terminology that H2O uses, but think of experiments as the model building process and the data sets. And you can see I've already got within this project, I've done a Walmart demand forecast project. I've got some training data sets. I've got a test data set, and I've already run 4 experiments. If I go over to the data sets, so with the data sets, right, we've got train, merge, CSV. I'm going to go outside of driverless now just to show you a little bit of where that came from, the raw data, right? Because as we remember, driverless AI assumes that the data is already cleaned up and ready for processing. So I'm going to go over to Excel, and if you remember what in the Kaggle contest, it included 3 data sets. One was weekly sales, so it has store, department, date by week, and the weekly sales. So store 1, department 1, for the week of February 5th, 2010, the weekly sales were $24,000 and $924. And you can see as we move down here for store 1, department 1, here's department 3, 4, 5. So each of the 45 stores, and I'm going to move over to the other data set. So this is one of the key data sets that we're using. The other one I'm going to show you is features. So features, the features data set that Walmart provided it includes store and by date, some of the environmental things that were going on, right? What the temperature was, what the price of gasoline was, whether there were markdowns. And in the Kaggle contest, they actually did identify 4 holidays where they did markdowns: Christmas, Thanksgiving, the Super Bowl, and I believe Labor Day. Consumer price index, right? This is a measure of inflation, unemployment, and whether it's a holiday or not. So this is data set number 2. And then the third data set they provided us was simply the 45 stores. Okay. And this is by far the smallest data set, right? We've got 45 stores, and each of those stores has one of 3 footprints, right? A, B, or C. And each store also has a square footage, right? So that's what was provided is these 3 data sets: train, store, and features. And what we had to do, this is outside of H2O Driverless AI, because again, you really got to do most of the data engineering outside of driverless. What we did is we created a merged CSV where we combined the data that was in the trained CSV, you could see, as well as the features CSV, and then the store CSV. So we combined these all into one file. Myself, I did include 5 what I call engineered, really what I did here. And this is actually good. This will be part of the demo that'll be interesting, right? This engineered was just the data type, and basically I split the training data and the test data, because we're going to have 2 data sets. We're going to have the training data set, and then we're going to have a test data set. The test data set is basically going to test whether our model is accurate or not. The training data set includes all of the weekly store data for the 45 stores. Again, each store has approximately 98 to 100 departments for 2010, right? You can see 2010 and 2011. And our test data includes the store data for 2012. All right. So really, column A here, 2/3 of the data, basically 2/3 of the rows have train, and the for 2012 we have test in that as an entry. We also took, what we did is we thought this would speed up the processing. We took the weekly sales and we quote engineered a new field to make it an integer rather than a currency or dollar, in the thought that it might speed things up. It really didn't, but it'll be interesting to show when I go through the demo. Just keep that in mind. So that is basically what we've done in our training data set. So that represents merged, right? We've merged the 3 individual files that Walmart provided us into merged, and then we split it into train and test. And train contains the data from 2010 and 2011, and test contains the data from 2012. Now let's take a look at, right, because one of the powers that we saw earlier was the visualization. And so let's take a look at merge, for example, and we're going to look at the details. The details aren't as exciting, but basically this just shows you, for example, I showed you in column 1, right? That was one of the engineered, self-engineered columns or fields, is X data type. 70% is train and 30% says test. That's the value. 2010 and 2011 says train in the rows, and 2012 is test. And as we move across, we could see, for example, here's store. You can see it does some statistics on here, right? It does the mean, min, max. It tells the storage type, whether it's a string, integer, or dollar value. If we go across, we can see some of these other items like weekly sales is going to be very important, right? That's what we're predicting. If I go to data set rows, this is actually really a replication of our CSV. Our Excel data, right? And this is page 1, where I've got basically what I showed you in Excel from 2010. If I go to the last page here, you can see that the date here is October 26, 2012. It is true that Walmart did not provide data all the way through 2012. It didn't go to December 31st. But you can see the weekly sales, the holiday. This is store 45, department 98. And so that is basically the data that we're going to be used to train and test. What else do I want to show here? So let me go to here. Let's look at visualize. So visualize is, you're going to see, remember that H2O had hired away one of the chief visualization officers from Tableau. which is really famous for their great visuals. And you could see that these, and this is dynamic, right? These are some of the visuals that come up for us. I'm going to show a couple of them. Let's look at outliers, right? Outliers are always key, right? And you can see that this is an outlier plot for markdown, not so important. We're going to carousel around to what is an important field, weekly sales, right? That's what we're predicting, weekly sales. So our training data has some outliers. So we have to take a look at these outliers to see if they truly should be really cast away or thrown out, or if they're legitimate. And actually, in this case, it's legitimate because this is Black Friday, right? So we're seeing excessive sales at this store in this department during the week ending November 26, 2010. And we can clearly explain that as Black Friday. And I'm not going to go through the other two dots on the graph here, but the same thing. It's basically Black Friday type of data. So this carousels around. This is fuel price. This is a great visualization. Another nice visualization that I like is, for example, the correlation graph. If we take this out, again, what we're predicting is weekly sales, right? We always have to keep that in mind. And remember, I quote engineered a field to convert weekly sales from currency to integer. You would expect that to be highly correlated, and that's exactly what you see, because it's the same exact value between weekly sales and the integer value of weekly sales, right? So it's highly correlated, but you can also see from this correlation graph what other features are correlated to weekly sales. And if I move this slider, basically the slider moves from blue. The blue is cold, it represents cold, not so correlated, not so much, to red where it gets hotter. And you can see for weekly sales, and I'm going to pull these apart a little bit, hopefully. It just gives you a visual of what are the important fields for forecasting weekly sales. And you can see the type of store is actually important, which is a little surprising. So some of these things that H2O Driverless AI brings to the table is intuitive things that we, as IT data science professionals, would intuitively think, but it also brings about some non-intuitive correlations. And that's really where a lot of the secret sauce is. If I reset this, let me go back and let me get this close. I'm going to double click on weekly sales. And you can see that for weekly sales, what it's saying is what's going to be important is markdowns, the data type, the date, and the time of year. Right. So it's giving us a hint as to what features are going to be important in our predictions. The last one I'm going to take a look at is they're going to provide some recommendations, right? And so some of the recommendations they're providing us is for the fuel price that they provided. They're saying take an inverse transformation of the fuel price. Okay, that's great. And that probably, and I'm sure it does make sense. Here's another one, department. What it's saying is take the square root, transform the regular department, and take a square root of it. It's saying to do that. But quite honestly, that's really what the secret sauce of driverless AI is. That's what it brings to the table, is it figures out what are the proper transformations to do on the original features. So we're going to let them do that. Let's see, if I go back, so that's the data set visualizations. I'm going to go through here. Here's some experiments that I've already run, some diagnostics, machine learning interpretability, report, deployments, resources, and a couple things I'm going to point out here, right? I'm a systems architect. I'm not a software person. I'm not a data scientist. But if I was, I could actually, instead of doing it through the H2O Driverless AI and doing point and click, I could actually use a Python client or an R client to interface with driverless, okay? The other thing I want to point out is system info. This shows us what information is, what the infrastructure is that we're using. And again, we're basically borrowing part of a system that's sitting in Poughkeepsie, New York. And they've given us one GPU, one NVIDIA V100 GPU. They've basically also, as you can see here, they've really given us, it looks like eight physical cores of a Power 9 processor. And you can see the CPU cores, really these are virtual cores. Now, one of the other advantages that IBM Power has over Intel-based servers is that we support 8 threads per core. And actually for these type of systems, these scale-out systems, it's 4 threads per core, whereas Intel-based systems, it's 2 threads per core. So for this particular AC922, Power AC922, I have 4 threads per core, and as I already mentioned right down here, we can see that we have 8 physical threads, okay, 8 physical threads, but we have 32 virtual threads. If we were using an Intel-based server, it would be basically 16 virtual threads. So we have more compute capacity via the threading capability that we have. And you can see the amount of disk that we used and the virtual memory and the GPU right now, we're not using it, so it's at 0% utilization. Oh, I forgot to go full screen on this. It'll help you all see, hopefully. All right. All right, so let's go back to projects and let's create an experiment, okay? So within our project, we're going to go into Walmart Demand Forecast Project. And you can see we've already assigned our training data set, which is the MVP, minimum viable product training data set. And you saw that represented basically the data from 2010 and 2011. I showed you that earlier. And we also have the test data set, right? The test data set is held back, it's held out, right? What we do is once we get done with the training, we use the test data set to test whether it's accurate, right, or not, and whether it's ready to be basically deployed out into production to do real life inferencing or predictions, okay? Over here, we've got some previous experiments that I've run, but I'm going to create a new experiment for this demo. All right, not now. And we're going to call this Walmart Demand Forecast. All right. And the data set that we're going to use is the training data set. Again, that's the aggregated. Remember those 3 individual files that Walmart provided us? We combined them into one, right? And now we're going to set up our experiment. You can see that for the years 2010 and 2011, across 45 stores, and each store having 98 to 100 departments, we've got 294,000 rows, 22 columns. Really, columns represent features. We're going to select our target column, and as you remember, what we're predicting is weekly sales, right? If we wanted to, we could weight particular columns. You can see what's happening over here to the left, right? Is it's providing us a description of training. Actually, I'll get to this in a second. Let me keep moving over here in terms of the setup. I am, in the spirit of time, going to drop a number of these columns, right? You remember these columns. These are all just the columns from our CSV file that we had. And we're going to, this is going to say drop them all. I'm going to keep this one, right? This is the one we talked about, data type. It was train or test, right? It's probably not meaningful, right? Intuitively, we can say that this is not meaningful for predicting weekly sales into the future, but we're going to include it there to see how driverless handles it. We're going to have store, department, date. Let's put in the temperature and fuel price, and whether it's a holiday or not. And so those are the fields that we're going to keep, right? So we've got 22 columns. We dropped 14 of them, really so that we can get through some of this experiment while we're on this meetup. Validation data. So one of the things is we don't have a validation data set, and actually for time series models, H2O doesn't allow them, right? But we do have a test data set, as you remember, and that represents all of the data across the 45 stores, each store having 98 departments for 2012, for the year 2012. So we're going to be training our model on data from Walmart for the years 2010 and 2011, and then we're going to test the accuracy of our final model using the data from 2012. And if it's deemed worthy, then we're going to deploy it out actually, for this, we'll probably deploy it in our data center for production use, and so that we can make predictions on sales for each store and department in 2013, 14, 15, 16. You get the idea. So we've got that. I have the time column off. So right now it's not set up as a time series problem. I do want to go down here right now just to show you that. So for the non-data scientist, what the experts, right, the Kaggle grandmasters and masters deemed are the most important are these knobs that we can turn, right? Accuracy, time, and interpretability, right? These are the knobs that we, as a user, can adjust. And there's definitely a yin and yang relationship, right? The more accurate you are, typically you're going to take more time, and really you're going to have less interpretability, right? Let's take a look over to the left here. If we look at the current settings, accuracy, we look at accuracy, provide some details, right? As we already saw that we have 294,000 rows of data that we're going to be training on, and I dropped all but 7 columns. The final pipeline right now is an ensemble of 10 models, right? And ensemble, it just means you're grouping together or combining 10 models together. The time is basically the feature evolution or feature engineering. More commonly, terminology here is 91 iterations. And just keep an eye on this, right? For the accuracy, right now we have 10 models, and for feature engineering, we have 91 iterations. Let me just crank this up to 10. We'll see what happens, as well as the time. And we'll reduce the interpretability. And really, accuracy of 10, time of 10, interpretability of 1, which means it's not going to be very interpretable, changes a lot of things, right? We're still using the same data to train, right? But the ensembles now you can stack up to 20 models together, right? The time, right now we can do 702 iterations, far more. So we're not going to do that because it'll take too long. I'm going to knock these down. I just wanted to show you that. I also have to remember to go over to our time column, right? We have to, because this is a time series, and time series is very common in data science. So it's important that H2O Driverless supports it. And our time column, of course, is date, right? And you can see what's happening over to the right is we're getting some time series specific settings that we're going to have to potentially adjust, or we could take the defaults. While that's setting up, the other thing I want to show you is that there's a score, right? Well, there's a couple things. There's 2 main domains or categories of machine learning. One is regression, and that's what we're doing, and the other is classification. If we think back to the PowerPoint presentation, right, and I kind of highlighted the PayPal one because of that IBM equipment. And basically, they're doing fraud detection, and they improved the fraud detection from 89% accuracy to 95% accuracy. That's binary, right? Is this a fraudulent PayPal transaction or not? So that would be a classification problem. And so those are the 2 large domains of problems that driverless addresses: regression and classification. The PayPal one was a classification. Is it fraudulent or is it not? Yes or no? This is a regression, right? And for regression, you get a set of scores that you use. And what we're using here, the score that it defaults to, and I'm going to take the default because I am not an expert data scientist, but it says root mean square error is probably the best score of your model. I could have picked some of these other ones, like I think this is the mean average. I forget what that is actually now. Mean average. Anyway, we're going to now. This is a place actually that if we wanted to remember what was bring your own recipes. If you had your own what we'll call recipe, if you had your own score, you could actually add it in here via the bring your own recipe function of driverless. We're not going to do that. The other thing I want to show you is expert settings, right? I'm a novice data scientist at best, but if I was an expert data scientist, I can go into these expert settings and I can really tune things, right? You can see all the different tabs and all the different knobs that I can change. General, model, time series specific knobs that I can enable, disable, change the settings of. Natural language processing, right? Which is really deep learning, right? That's the one area that they do use TensorFlow for natural language processing. It's a little bit of their deep learning niche. Everything else is machine learning. We can adjust the system resources. Basically, the resources that we're showing here, the settings are saying use all available resources. If we had some custom recipes, we could add them, right? Here's the official recipes, right? These are, and again, recipes are nothing more than Python code, right? These are the official recipes. You can load your custom recipes, upload custom recipes. So there's a lot of extensibility that Driverless AI provides you. We're not going to touch any of them. You can see it's GPU enabled. The time series grouping, this is another thing that we're going to do. We're going to let H2O Driverless AI figure out what is the right grouping. What we probably gathered by now is that we want to know what the sales are, what the weekly sales are by store and by department. So hopefully it figures out that it groups its prediction by store, by department, right? Because while we're not using the test CSV, right? That would be a bad practice, worst practice, right? And provide leakage, quite frankly. The forecast horizon is 33 weeks because it does know that in our MVP test.csv, we have 33 weeks worth of data. It's not a full, it only goes to October. I think I showed that. We'll just move this just for expediency to 8. So we're going to take the next 8 weeks. So this will basically be using January of 2012 and February of 2012 to do the testing of our model. There is no gap. If there was a gap between the training and test data, we would enter it here. So I think we're all set and ready to go and launch this experiment. And let me do that. Let me crank it down even more. It's not going to be very accurate and the time is not good, right? But we want it to get through this. I want to make sure everything's set properly. You can see when we've cranked everything down now, we're only going to do 12 iterations of feature engineering, which is good. And one thing that's unique to time series, which is what I did last, right? I entered a time column here. So I basically told Driverless that we're doing a time series model, is that we can't do ensembling or stacking of models together. And basically we're using 2 different variations of gradient boost machines, which are very popular actually now. They're proven to be very accuracy, not only for regression type of problems, but also for word finding problem here. For the other one I was talking about, it'll come back to me in a bit. So LightGBM is it's a variation of gradient boost machine that was pioneered by Microsoft. And XGBoost gradient boost machine is just another implementation. So it's variations on a theme of gradient boost machine. Okay, let me launch the experiment. If you look up in the middle quadrant here, you can see it's running the experiment, it's preparing the data. You can see over here, time groups column, right? We let this go to auto. Hopefully it's going to figure out that we want it grouped, by store, by department, by date. It's preparing validation splits. These are the settings that we had, 221. We're using as I mentioned, the root mean square error. Here you can see the physical resources that are being used, the CPU as well as the memory. You can see that in two parts here. You can see the first thing that it did is it dropped column 1, right? Remember we put that in there? That was one of my quote engineered columns. It was the data type, and the data type basically had 2 values. It was either this was training data or test data. So it was really not of any value in doing predictions. So it dropped it. It also made some other notifications here. So I am going to drop this. I am going to go over to notifications and see what it's telling us. The font here is bigger. And drop 1 column, we already went over that. It dropped 1 column because it's not going to provide any value to the model that it's building. And then the other thing it notices that the learning rate, which is one of the hyperparameters for turning and feature evolution, is larger than the learning rate for the final model. So learning rate is one of the key hyperparameters, and it made an observation, and basically the action it's saying is please wait for final score. So it's giving us some recommendations, right? And basically what it's saying is don't hit this button right here, finish, okay? So you can see that right now it's doing a number of things, and all the things that it's doing right here is identified. We're tuning 0 of 9 parameters, feature tuning the models. Pretty soon we're going to see some action down here in the lower left quadrant, as well as the lower middle quadrant. Over here we can see actual versus predicted once it starts running. And we can also see the GPU usage. You can see that right now, as it's setting up the experiment, and again, what it's doing when it's setting up the experiment are all of these things. And you can see it just runs through here. So the CPU is pretty much pegged. And really what we used were 8 physical cores, as you remember, when we looked at the system info, right? And the memory is being utilized as well. And what we're hoping for is within the next couple seconds that we get some action over here. Y'all, while I'm waiting for that to happen, have any questions come in, or is the audio still sound good?
You sound great. Manny has told us that MAE is a mean absolute error.
There you go. That's the one I forgot. Yep. Very good. Thanks, Manny.
I can make a comment, which when I met you in person, we talked about it. You could see that when it explains, or when some things are written in text, it uses terms of evolution, like a feature evolution, etc. And that got me very curious, because I'm very much into genetic algorithms and evolutionary computation, pretty much the same thing. And I was wondering if there is any kind of genetic algorithms used here behind the scenes, and it looked like they are used here. And genetic algorithms generally are a very good way to find the best combination. So when you have a huge amount of combinations to choose from, and you have a criteria which makes one combination better than other, in this case it's the RMSE, or whatever it is that you chose. So for example, you can use genetic algorithms to find the best features. If you want to drop certain features, you want to do feature selection, or if you want to find the best combination of algorithms, or the best hyperparameter combination for an algorithm, etc. So I was actually very pleased to see that it seems like it's used here behind the scenes. And
Yeah.
I plan to talk about genetic algorithms probably in one of the future meetups. I'm sorry. What were you saying?
I think that's a great comment, EL. And we did see, right, that when we did this in Jacksonville live, which I'll be honest with you, it's easier to do things live than virtually, I have to admit. I'm learning that now. We did see, right, that the masters and the grandmasters of H2O do use genetic algorithms behind the scenes, and I know you've written a book that's out on Amazon around genetic algorithms. So that is neat. So what's happening now is we've got 5% complete, and I'm glad now we're running. So what's happening down here in the lower left-hand quadrant? Well, again, what we did pick was RMSE, root mean square error. That's our scorer, and the value is in actually in dollars, right? So it's not anything fancy, but this is what we're running. The model that it's testing, right? We saw that it's going to try light GBM, which was pioneered by Microsoft, as well as XGBoost. Okay, so right now we're doing light GBM, and we're going to do many iterations during this process. And the whole goal here is we want to reduce the error and improve the accuracy. So each iteration, with each iteration, we learn something that we can take. With each iteration, we learn something about the model, right? Because what we're doing here is we're doing an iteration right now with light GBM. Light GBM has certain hyperparameters. We're also using these features. So over here, and they call it, H2O calls it variable, but really we think of them as features and we call them features. So this is feature engineering. So basically what it's doing is it's big animal picture is it's trying, in our case, two different models, light GBM and XGBoost. With each of those different models, it's adjusting the hyperparameters for each iteration to see what hyperparameter are optimal and get us more accuracy. And more importantly, or just as importantly, it's also doing feature engineering. What features are important to improve the accuracy of our model? And again, what is our model is sales forecasting or demand forecasting.
Jerry,
Okay.
can I interrupt you for a second? We have a request. Is there a way for you to increase the brightness of your screen?
I could try. Let's see here. Brightness. Let's try this.
Yeah, it looks like you did it, but it does not make a difference for us, or does it? But keep it like that. Perhaps there is some difference.
Okay. Yeah, it's actually it is bright for me, but sorry about that. Okay, so what I want to show here is, right, for each run, you're going to see here are the features, right? And what we see here are the original features like department, store, consumer price index, right, down here on the bottom, right? But what it's also done is what's called feature engineering. It's done modifications to the original features. In this case, we have EWMA, lag of date, department, and store. So it's taking the exponential weighted moving average of date, department, store. And what does that really mean, right? So I would never, right? This is completely non-intuitive to someone who would think to do that. Well, data scientists, the best data scientists would think to do that. And what is basically doing exponential weighted moving average is it's placing a little bit more importance on the values for date, department, store for the previous week. So, right, what we're trying to do is predict the future, and what exponential weighted moving average transformation of the original fields or features are. What it's trying to do there is make more important the most recent values for date, department, and store. Okay. There's also other features you can see here. Target lag, lags max. So, again, this is part of the secret sauce that the H2O company brings to the table. The secret sauce that IBM brings to the table is we get the training done quicker. VR GPU enabled power servers. And you can see as we move through here, right, we're still doing light GBM, but as it moves through here, right, it's learning from the previous run, from the previous iteration, and it's making adjustments because ultimately we want to drive down the error here, and the curve should be going like this. Right now, we're just using CPUs and memory. We are not using GPUs yet. I'm going to let this run.
I'm sorry to interrupt you again. I have another suggestion. Lower the contrast and increase the brightness, if you want to try that.
Okay.
A request slash suggestion.
Okay. Any better? Not really.
It's easy to judge because I see it in a different view than everybody else. Let's see
Right.
if you comments. Keep it this way if you can, and we'll see.
Yeah, this is a little bit of the challenge of. So this is going to run. We'll come back to this. I'm going to go over to an experiment that I ran yesterday or the day before, and we'll take a look at that. And you can see before I do that, you can see that what in real time exactly what Driverless is doing. Right, scored 13 of 41 models on 68 features. Right. Right now, it's running another iteration of Light GBM using these features right here. And the other thing I'll note that I don't think I noted was, it assigns an importance to each of either the original features, like department, has an importance of 0.14. The exponential weighted moving average of date department store looks to be very important because it has a relative importance of 1.0. All right, let's go over to, while this runs, a finished experiment. All right, so you can see so this is the one we're running right now, right? It's 32% done. It's run for 25 minutes. Here's several other experiments that I ran with different accuracy, time, and interpretability, right? These are the big animal picture knobs, the big knobs that they provide accuracy. So I wanted this one to be pretty accurate, but I didn't want to spend a whole lot of time, and I didn't necessarily need it to be super interpretable. And I actually used a different score, MAE, and it was completed. It took 10 hours to complete, right? If you look at this one that I did, when I had the accuracy, time, and integer, again, the big animal knobs at 552, this completed in 42 minutes, right? And again, I am using 8 physical cores of a Power 9 system in Poughkeepsie, New York. So, I mean, I do not have a lot of resources and 1 GPU, right? In a production environment, you will typically have, you'll have, well, with IBM's AC922, we support up to 6 GPUs, 6 NVIDIA GPUs on a power server, and you'd be using all the cores, all the RAM, all the GPUs. And then what H2O right now is working on is allowing for clustering, right? Right now, driverless just works on a single system, and you can max that single system out, as I just mentioned, with as many GPUs as it'll support, as many CPUs and cores, typically 2 CPUs, and 20 cores per CPU, for example. And an IBM system, one of the advantages is our memory. We support up to 2 terabytes on these systems. Intel-based systems usually 1 terabyte. And then we do have that high-speed bus between the server, CPU, and memory, and the GPU server memory. Because interestingly, right, if you think of what we've been used to over the last several decades, CPUs, right, they'll have anywhere from, whatever, 16 to 28, 30 cores per CPU, but they'll have a lot of memory, right? Like I just mentioned, 2 terabytes for the Power 9 server, AC922. If you look at the NVIDIA GPUs, it's really just the opposite, right? The latest NVIDIA GPU is V100, and it has 5,120 cores, okay, and only 32 gigabytes of memory. So having a high-speed bus between the CPU, the Power 9 CPU, and the Power 9 system memory, which supports up to 2 terabytes, is very important and a differentiator for IBM, because the GPU, while it has over 5,000 cores, it has just a tiny amount of real memory, right? Like I say, the latest just has 32 megabytes. I mean gigabytes. So let's go to, you can see this is 39% done. Let's go to this one that I ran yesterday or the day before and take a look at it. Because the screen will look much like, once ours that we're running now finishes, it'll look much the same. And what you can see here, right here are all the iterations that it ran through, and what you wanted to see is the curve going down and down. And as you can see, as I move my cursor, right, each of these iterations have different variables. That's why the variable importance is moving, because each run uses a different set of original as well as engineered features. And finally, it comes to a conclusion, and it says this is the best model. And we can see it was Light GBM, even though it tried XGBoost. In this run, Light GBM came out as the best model, and these features were the best for accuracy. So let's take a look at this. Let's download predictions. So, right, we tested on the training, MVP train, CSV. That's what we trained our model on. We completed the model. And now what we're going to do is take a look at our test set. So now we have our test set, which was absolutely not used in the training. Whenever, and that's easy for time series type models, but whenever test data it somehow gets intermingled with training data, that causes leakage. And what it does is when you go to test your model, it shows an accuracy that's, you know, inordinately high. And so when you deploy it out to production and it doesn't, and your model doesn't do well and it's forecasting your predictions, then you might have had some leakage between your training test data. In this case, we didn't. And so I am going to go to test, and I'm basically just going to pick the key ones: store, department, date, weekly sales. So now, again, this is a completed model, and we're running. It has not seen this test data, right? But it is going to score on the test data, which is basically data from 2012, as we remember, right? It's coming up. Taking a little bit of time. All right, so I'm going to make this a little bit more readable. Oh. All right, so you can see, right, for store one, right, we've got departments 1 through 98, 99, and we've got 45 stores, and we're doing our predictions on data from 2012, right? What were the weekly sales in 2012? We did not, I repeat, did not use this during the training, right? We held this back to see how accurate our model was. And I am going to get rid of the dollars, and we'll do some real quick. We'll get rid of the decimals. For one. And the delta in dollars is this minus this. Okay, we'll copy that. Just for a few. We're not going to overdo this. And then maybe a little bit easier is the percentage delta equals, this was the delta divided by the original. All right, and we're going to make that a percentage so it's easy, more readable. All right, percentage. Oh. All right, so the first entry wasn't awesome. You can see, so for this particular model, right, it was pretty accurate for some of the departments, right? Here was the actual weekly sales by store, by department, by basically this is the first week of 2012. It was pretty good, but for some it really overshot, right, or undershot. So this particular model run was okay, but we could probably do better. I will bring up, for example, one that I had run that I really had cranked up. I really had cranked up the accuracy as well as the time to execute. And you can see that in this case, the delta between the actual weekly sales in 2012 and the predicted or forecasted weekly sales, that's the raw dollars, and that's the delta, was pretty good. You can see there's really, everything was in pretty much, there was nothing worse. Well, that's 4%, that's 5%. 5% we could probably attribute that because it was a department with very small, few amount of sales, $187 worth of sales. So you get the idea. So that is that. Let me just go over and see how our we already did this. Let me also do a couple other things here. So let me do this. Let me just make this a little bit smaller for a sec. And I am going to go over to, okay, so I could download, let me do this. Let me do this. Make this bigger. So the other nice thing that H2O Driverless does is it provides an awesome, excellent experiment summary. So for the one we just ran, or actually, let's go back and see if ours is done. It's 46% done. It's not quite done, so we can't run that. So let me go back over to this one and download the experiment summary. It does a magnificent job of explaining the experiment, and there's a lot of extraneous information in here, but for the report, what we can do, and again, this is automatically generated by the Driverless AI software. All right, so this is a Driverless AI experiment. Again, it's the Walmart. I used a different score in that case to do the demand forecasting. I did it yesterday, and it gives you all of this information. The software builds this on your behalf. The first thing that's important, of course, is the experiment overview, right? And let me just highlight that. No, I can't do that. The experiment overview. So basically what it said is, for this experiment.
Zoom in a little bit?
What's that?
Can you zoom in a tiny bit? It's on 100% at the moment. Maybe make it 120 or something like that.
Sounds good. Let's see. Better?
Yes, that's great.
Okay. So this is the report that is automatically generated by Driverless, and for this run that I did, right, it basically said Driverless AI built one light GBM model to predict weekly sales. That's what we've been doing. We use 6 original features from the input data. That's the same one we just used, training, right? The regression experiment, because I had accuracy and time cranked up, it took 10 hours. Plus, I don't have a lot of resources in our Poughkeepsie Center, as I mentioned. It used 2 of the 6 original features, right? And 24 of the 1,192 engineered features. So it did a lot of feature engineering, and it found 24 of them to be very good. So 24 fabricated or engineered features and 2 original features it used. Let me go down here. You can see the settings. In this case, for accuracy, I use 7, times 4, interpretability 4. Again, this isn't 32 CPUs. This is basically 32 threads, 8 physical cores, 4 threads per core, and only 1 GPU. So, and it was using this version of Driveless AI. They've since come out with 1.8.x. And again, it tells us the number of columns, right? Columns are basically features or potential features. Obviously, I dropped a bunch of the columns in the interest of time, but all of them could have been features used to help improve the accuracy of the model. For the training, right, it was split between 2010 and 2011. Had this many rows. Test data had basically a third of that because it was 2012. If I move down here, it gives you some statistical data about the actual data that was used, right? And it does it by data type. So first it starts with the numeric columns, the Boolean columns, and really we only had 1 Boolean column. Is this a holiday or not? Categorical columns, and then shifts detected. Now, data shifts are important and can, just like leakage, can lead to problems when you roll it out in production. Because what it's saying is typically, not in time series, okay, but typically if there was a data shift between your training data and your test data, you got to be concerned that because you basically trained your model on your training data, and if your test data is different, significantly different than your training data, you're going to have potential issues when you roll it out in production, right? It won't be. It's kind of the opposite of leakage, right? We went through leakage. Leakage meant basically your training and test data somehow got melded, and that when you rolled it out in production, it wasn't accurate at all. So if we go down here, let me just show you. But with time series, it's not necessarily the case. What it did is it detected a difference in the consumer price index, and it has a nice graph. And there were actually, I think, 3 fields in this. And that makes sense, doesn't it? Because we were doing time series, right? So the training data set in blue was basically depicted data from 2010 to 2011. And the test data set represented data from 2012, right? And so what we're saying is that inflation was higher in 2012 than it was in 2010 and 2011. And that was the case. So that's okay. So that was a data shift that was explainable. If we look at another one here, this was temperature, right? This might play into the whole global warming thing. It's saying in green, the test data 2012, the temperature in 2012 was higher than in 2010 and 2011, our training data set. So it just highlights potential data shifts that you have to be aware of. Again, for our time series, they were very explainable. If it was not time series, then we might have an issue and might have some concern that the training data really isn't representative of the test data, and therefore when we put it out into production, it may not be that accurate because the data from, for example, 2013, like the data from 2012, may not be representative. Let's see if there's some other interesting things that it showed. This is nice. It does a real nice job of explaining the whole H2O Driverless AI pipeline, right? And we saw all that in the demo, ingesting data, right? We had the 3 CSVs. Outside of driverless, we had to aggregate those into one CSV. And really, just I did forget to mention, where did that data come from? It came from the Walmart sales enterprise system, right? So whether it's JDA or whatever sales system that Walmart uses, those CSVs came from that, right? And then we basically aggregated the three CSV files into one so that it could be accepted and ingested by H2O. Let me just, sorry. This tells you a little bit more detail of what it did. So during the, oh my goodness. During the model and feature tuning, right? It was looking for optimal hyperparameters for XGBoost and light GBM models. And it used 151 models to find the best model. And then what it did is it calls it feature evolution, but it's really feature refinement. You know, based upon the best model, it did some more iterations of more engineered features, and it did 92 iterations, 720 models. So it did more processing. Right, that's the magic. And then it came out with a final model and a scoring pipeline. And then it tells you how much time it spent on each of the major phases of the AI pipeline, from data prep. Not much, because really we do all the prep outside of driverless. Model feature and tuning, feature evolution, really that's feature engineering refinement, and then the final pipeline tuning. Really nice. There's a whole bunch of configuration settings. Some of this, remember when we went into expert settings, some of these are there. This is an interesting one, right? Feature engineering, right, is really about transforming the original features to improve the accuracy of your model. And what we saw, remember that one we saw was, we spent a little bit of time on, was the exponential weighted moving average lags transformer. That was one. There were other ones that were there that we didn't hit on, but these are all of the pre-built transformers that they include. Again, this is because they have really some bright and best of the best data scientists on their staff. Let's see what else we have here that might be of interest. So you can see there's incredible number of configuration settings, some that we can set, some that we can't. There is some interesting things at the bottom. That's why I am taking the time to kind of go through here. Let's see here. This provides a little let me just go to the bottom. Feature transfer. These are some of the feature transformations that it did, right, on the final model. Gives you more color commentary on that, right? We did see that the EWMA for date, department, and store had a very high importance. So it gives you what were the important features in developing the final model. You can see it did include one of the original ones, right? Department was an original. It wasn't transformed at all. It's an original, as well as store, an original, right? Let's down here. Okay, the final model. All right, here's the different scores. On this one, I did predict MAE. Typically, it defaults to the root mean square error here. There's some visuals that you can use, alternative models. So that's what I wanted to get to was, right here. Here are the models out of the box that Driverless comes with, and it immediately, just based upon the data set that we provided it, as well as our model setup, it immediately discarded, like, for example, TensorFlow. It knew this wasn't a deep learning problem, so it didn't even evaluate it, right? What it did know was that GBtree, and really this is XGBoost, think of this as XGBoost. This was almost, right? We did a lot of iterations with XGBoost, but it was not selected due to low performance during the feature evolution stage. And Light GBM from Microsoft was selected for the final model. And then you build a final pipeline, right? So hopefully that was all clear. So it tells you where the final pipeline is located. I popped that up. So again, remember there's two ways to deploy this. One is via the Python scoring pipeline. The other is the Mojo, which is actually better. It's got lower latency. It's better for real-time models. And let's go. So let's go back to H2O. I don't think there's anything more worthwhile here. Okay, let's just go back to Driverless. I downloaded the scoring pipeline before. Right. So what I would do, right? Once I've got to this, I would have two choices. I can download the Python scoring pipeline, or I could build and download the Mojo scoring pipeline. They're both very easy. If I, just in the interest of time, because I did already do this, I downloaded the Python scoring pipeline just to give you an idea of where to go. Oh. Oh my goodness. Well, let's see how quick we can get it. I'm not sure we're gonna have time oh, I might have put it. Yes, okay, I did do it, but I didn't expand it out. So what I would do once I'm satisfied that yes, this is the model for demand forecasting, sales forecasting that I want to put out into production, I would download the Python scoring pipeline, and here it is. Here's the scoring pipeline. I'm going to explode that out, and what it provides is text and information about how to get this deployed. I'm going to go to the README so you can get a feel for how we can deploy this. And for the Python scoring pipeline, there's two ways to do this. Now, let me make this bigger. Okay. The package contains an exported model, right? So our model is and the Python 3.6 source code examples for production. So the files in this package allow you to transform and score on the new data, right? That's the whole thing, new data, in a couple different ways. From the Python 3.6, from Python 3.6, you can import a scoring module, which we've created, and then use the module to transform and score the new data. Or from other languages and platforms, you can use either TCP or HTTP scoring service and do a call through RPC. So if you have an application, you can do an RPC to get to this scoring module. And so what you might have, right, once we built our model, we built it on data from 2010 and 2011. We tested it on data from 2012. It was at appropriate level of accuracy, and now we need it into production. And so we put that out into production, and it's ready to run. So that is and so once it's out in production, right, we've got our Python scoring pipeline. It can do predictions on, data from 2013, 2014, as I said. I think that's about it. There's interpret model for time series. It's not all that fantastic, but I think we're at the top of the hour anyway, y'all. So, and again, model interpretation is important for particularly regulated industries like financial and whatnot. So in my industries that I work in, retail and consumer package and travel transportation, not so much. So
I have you back on the, people can see you now next to the screen. Maybe I just show you alone, but we had one question here. Let me just maybe show myself as well, like this. Money is asking if he was asking, will you be showing the same training using the GPU on this server? Obviously, we didn't have time to show more things, and he said I was looking forward to see the training time between CPU and GPU versions. So perhaps you can give some information about that.
Well, right. So that actually does get back to one of the slides that I showed. It was the slide that had the observations made by the CEO of H2O, and in particular, I suppose I could bring it up. It basically, if you recall, it was a 30x improvement of power in our GPU-enabled server versus a non-GPU enabled server. So there's a couple different. Let me. There's probably two slides that could give him some insight. It does all depend on the model, right? But can you share my PowerPoint or no?
Yes, I'm sharing it.
Okay, can he see this?
He should be able to see it.
I mean, to me, this is one great example of the impact that GPUs have to training machine learning and deep learning models, right? That over the same time period, the CPU-only server, right, with two Intel chips, it trained and evaluated 36 models. And you can see that, and again, what were they trying to do? They were trying to predict income using US Census data from, I don't know what year, but it's a moot point. But that was the model, predict income based upon US Census data. And you can see that a CPU-only server has just started out the training process. It trained 36 models. If we go over to the left, we see a GPU server. In this case, quite frankly, it's NVIDIA's own DGX1 with 8 of their Tesla P100 GPUs. In the same amount of time, it trained 3,600. So, basically 2 orders of magnitude, what we call that? Order of magnitude times 2? I don't know. But basically, with GPUs, we were able to basically come into job on predicting income using the US Census data. And we just started out using a CPU-only server. The other one I'll show you, is this one. This is the slide, again, authored by the CEO of H2O, that talks about the fact that GPU accelerated machine learning. And you can go to this blog, and that's basically what he wrote is, and this compares basically our Power 9, IBM Power 9 GPU-enabled servers were 30 times faster in the training process than non-GPU-enabled servers. So GPUs are really one of the three fundamental elements of why AI has taken off. One is GPU technology. The second is the fact that we can harness big data now with technologies like Hadoop and Spark. And the third big element of why AI has taken off is because of all these frameworks that make things easier, whether it's in deep learning, TensorFlow or PyTorch, but also the software that we just saw today, right? H2O Driverless AI. Or the other one that I referenced early on was the IBM Visual Insights product, right? So those are the three things that are making AI what it is today. Hopefully that answered his question.
He is asking, would it take 3 to 5 minutes to train on a GPU if your training on a CPU took 45 minutes? If you think you can give an idea of like that?
Well, it absolutely. So on that one, what it showed was 30x, right? So on that particular one, the slide I showed, which was from the H2O CEO that had 30x, that was 30x faster. So, you know, if we're talking seconds to minutes, that's not a big deal. But what we found, especially with deep learning, more so, is that you can go weeks and months of training, and the sad part is that at the end of the training, you may find out that that was a terrible model, and you got to go back and start all over again, right? So, I mean, GPUs are one of the fundamental reasons why AI has taken off. There's no doubt about it. And, you know.
Okay, this was great. I don't want to run everybody's time and your time, but it was amazing. Very, very thorough. I thank you very much. This video will remain on the channel. Everybody that didn't get a chance to see it live or had to leave in the middle because of work can come back and see it. And over time, I think a lot of people will see it. They can contact us with more questions, and we can possibly contact and get answers from you if need be. And hopefully we will see everybody again next month with another presentation that we are working on. Thanks again. That was amazing.
Thank you, Al. Thank you all.
And see you next time. Goodbye for now.
Goodbye.